This video is going to go through a problem similar to Unit 3, Block 1, Mom Problem 7. The problem says that we have a total cost function, C of x equals 72,900 plus 700x plus x squared. It asks us to find the minimum average cost. So first, we need to find an average cost function. I'll call it A of x. Average cost is total cost of producing x items divided by the number of items produced. So we can take our total cost function and divide it by x, the number of items. I'm going to simplify that A of x function down before I move on to doing the calculus. When you divide by x, you divide every term by x. So I could write it as 72,900 is divided by x plus 700x is divided by x. So x on top cancels with x on the bottom, leaving just 700. Plus x squared is divided by x. X squared divided by x will just leave x. So this is a simplified way to write A of x. I'm going to do one more rewrite. 72,900 divided by x. I'm going to flip that x up to the numerator and write it as 72,900 x to the negative 1, and then plus the 700 plus x. I like this form better because we know that this is the form that is easier for us to find derivatives of. Okay, we want to take this A of x function and find when A of x is smallest, when it is minimum. We know the steps to doing this is to find the critical points, and then we'll use the first derivative test to identify if the critical points are local max or local min or not. To find critical points, I need to find where A prime is 0 and where A prime is undefined. So we need to find the derivative of A of x. Working with the A of x function in red here, I can just use the power rule. So its derivative, we're going to drop down that negative 1. We'll get negative 72,900 x to the negative 2, because we subtract 1 on the exponent. Derivative of 700 is 0, plus derivative of x is just 1. So here's our derivative function. We now need to identify where is the derivative undefined and where is the derivative equal to 0. Note that this function, a prime of x, actually could be written as negative 72,900 divided by x squared. Remember, x to the negative 2 is the same thing as dividing by x squared. So when you look at it this way, you can clearly see that x can't be 0. If you let x be 0, then a prime is undefined because you can't divide by 0. So I'll just note a prime of x is undefined at x equals 0. However, I'm not going to even call that a critical point because x equals 0 in this problem means producing 0 items. And you can't do that in the original A of x function. You can't ask, what's the average cost per item when producing 0 items? That doesn't even make sense. 0 isn't in the domain of the original A function. So we don't need to think about 0 being a possible minimum or maximum point. It's not. It's not even a point on A of x. All right, next. I'm still seeking critical points. We don't have any critical points of the variety a prime of x equals undefined, but we might have critical points where a prime equals 0. So now I need to solve for where a prime of x equals 0. I'm going to set my a prime function equal to 0. You could put this function in Excel and use Solver to find when it equals 0, or alternatively, if you want to solve this problem by hand, it's actually not too difficult. I'll just show you how you can walk through that by hand. I'm going to first add this fraction on both sides so that on the right side, that cancels out, leaving 1 on the right. And now it's 72,900 over x squared on the left. If I multiply both sides by x squared, the x squareds cancel out on the left, leaving just 72,900. And on the right, we have x squared. To solve for x, we take the square root of both sides. And technically, there are two answers, plus or minus the square root of 72,900. And if you go to your calculator or go to Excel and calculate the square root of 72,900, you'll see that you get 270. So the solutions to this equation are positive 270 and negative 270. However, the only solution we care about is 270 positive, because again, we're talking about items, and items sold can't be negative. All right, so you can again do that using Solver in Excel or by hand, like I just did. What we've learned here is that A of x has exactly one critical point at x equals 270, where A of x flattens for an instant. This is a potential local max or local min. Now we're going to use our first derivative test to identify if x equals 270 is a local minimum or a local maximum. So again, you can draw your number line. We're going to put x equals 270 kind of in the middle. We need to test the left side and we need to test the right side. So I'm going to evaluate a prime of how about 200, and we'll also calculate the value of a prime of how about 300. One to the left, one to the right. We need to know, is a prime positive or negative? And then we'll be able to make a conclusion about if this thing is a maximum or a minimum or neither. I'm going to go into Excel. In Excel, I went from 0 items where the average cost is not even defined up to 340 items is where I stopped. I put A of x in column B, the average cost function. I put A prime of x in column C, the derivative of average cost. And I drug the formulas down. X equals 200, we get a derivative value of negative 0.82 approximately. And at x equals 300, I see we have a derivative value of 0.19. So I can now say on this interval to the left of x equals 270, a prime of x is negative. And on this interval over here to the right of x equals 270, we can now say that a prime of x is positive. Therefore, we know over here to the left of x equals 270, a of x is decreasing. And on the right side of x equals 270, a of x is increasing. And so now we can visualize a of x is going down, flattens at 270, and then goes back up again. So we can say that a of x has a local minimum at x equals 270. So when selling 270 items, the average cost per item is smallest. If you go to your function a of x and you plug in 270, I'm just going to do that right here. I'll highlight that in red. We see when producing 270 items, they have an average cost of $1,240 per item. You see it's a critical point because the derivative is 0. To the left of it, the average cost was decreasing. To the right of it, the average cost is increasing, so it's definitely a minimum. And we can now go into MyOpenMath and put in 270 items. The average minimum cost was $1,240 per item.